Okay, so today I'll talk about some of the best practices, tips, and tricks for getting the most out of your Hadoop cluster. We will look at some of the areas such as how do you build the cluster, how to get the configuration right, commonly made mistakes and how not to make them, how to monitor the cluster and run the cluster reliably. We'll also go over how to set up the cluster for multi-tenancy and what are the tools that is available. Let's start with hardware and cluster sizing. In case of Hadoop, given it's a scale-out system, the bigger the cluster it heals faster and it is more reliable. Second thing that needs to be understood is if you have more denser machines in the cluster, when the machine goes down, it takes a big percentage of the cluster down. That means that these kind of machines, when they are lost, it takes longer to heal. It takes bigger percentage of the cluster. The other thing also to note is the default block placement policy in Hadoop considers rack. So the more the number of racks, you have more failure domains available, and hence better reliability. Some of the recommendations based on these considerations is when you are choosing the hardware for your Hadoop cluster, choose a good quality commodity hardware. Commodity hardware doesn't mean that something that is of poor quality. Also, when you are buying your hardware nodes, make sure that you go for sweet spot pricing instead of going for the latest and greatest CPU that's available. Typically, this is 3 terabyte disk. Now that some of the Hadoop applications have become a lot more memory hungry, you may want to choose around 96 gigabytes of memory, 8 to 12 cores. These are for the data nodes. And yeah, feel free to ask a question given the room is quite small. And before considering larger machines, that is today, in the past 3-4 years ago, we used to have data nodes that were 4 disk, 1 terabyte machines. Now it is 12 disk machines with 4 terabytes. That is equivalent to 48 terabytes on a single node. So before you choose nodes that are denser, make sure that your cluster is grown to a size where around 30 to 40 nodes are multiple racks, and only then consider going for denser nodes. The other thing that is key is before choosing the nodes, if you are running a POC or you have a test cluster, run your workloads, understand your workload patterns. Again, workload patterns keep on changing in Hadoop cluster, but it is good to understand your workload patterns, whether it is memory bound, CPU bound, or IO bound. And based on that, you may want to select nodes that with higher memory or more spindles, or possibly more number of cores. One rule of thumb is make sure that you consider the network, the switches, the cost of that as around 20% of all the hardware. There's an excellent article written by Eric Balderschwiller, CTO of Hortonworks. I have a link for that has a lot more details. So now that you have a cluster, what are some of the configuration, the mistakes that are made, and this comes from my experience of supporting many clusters. One key thing is all Hadoop daemons are Java daemons, so they're written in Java, and making sure that you've configured your JVM is very important for the better performance, in some cases, reliability of the cluster. We have been using, in the past, 32-bit JVMs for data nodes. Now, I recommend going to 64-bit JVMs, given that compressed object pointers are enabled by default in Java. That means it is stable. I recommend running, all the daemons with 64-bit JVM. This is key because I've seen, many clusters where because the data nodes are denser and the disks are, disks have higher capacity, the 2 gigabytes or 4 gigabytes that we used to configure data nodes with is limiting, and data nodes do run out of memory. As regards to Java heap size, I won't go into the details of how to configure the Java heap size. There is a lot of information available, but make sure that you set some of the JVM configuration parameters right. One thing that I suggest doing is setting the max heap memory that you have configured same as the starting memory. This makes your Java process, the garbage collection, more predictable. Also, for some of the key Java parameters, avoid using defaults. One example is Java young generation size. I have seen that in one of the Java releases, the young generation size default changed to 1/3 of the total heap size. This resulted in old generation getting lesser Java heap and has resulted in, in some cases, out of memory errors. So my recommendation is to configure young generation size depending on the size of your JVM, anywhere from 1/8 to 1/6 of your total heap size. 1/8 for Java processors that are, tens of gigabytes. Also, make sure that you use low latency garbage collection for all your processes. Right now, the stable one is concurrent mark sweep GC. I don't know, I've not had much experience with G1 collector or what the state of that is. Another thing to make sure is configuring parameters where you can collect garbage collection logs with enough details. This helps in finding the problems in terms of sizing the JVM or any overload conditions. So make sure you have garbage collection logs logged with enough details. Also, configuring things like dumping heap on out-of-memory errors will also help in debugging a lot of cluster issues. Going to the next set of configuration that is important for the cluster. This is a very well-known one, but I'll repeat it so that in case somebody doesn't know, they do configure their name nodes with multiple storage directories. This ensures that the name node metadata is stored in multiple storage directories. There are multiple redundant copies. In case a disk fails, you have another location from where you can restore your metadata from. Also, make sure that one of your storage directory is NFS mounted. That way, you have metadata stored external to the name node hardware itself. And when you're configuring the mount point, use soft mount with timeout. We have seen cluster issues where hard mounts results in name node getting stuck because there is no timeout. One other key thing that I see, and I've solved many issues related to this, is either because of how someone uses daemon tool or they've not configured. The open file descriptor ulimits are sometimes not configured. The default 1024 is way too low for Hadoop daemons because of opening of a lot of files and sockets. I recommend configuring upwards of 16K for data nodes, and for master nodes, 64K as the U-limit. You can go even higher than that. But without this, you would see data nodes not being able to open socket connections or other fail to open file kind of errors that you could avoid setting this up. The other thing that I've also noticed is you need to make sure that your cluster nodes are time synchronized. I've seen failures because of this where token expiry, for example, tokens are considered expired even though it is not because the nodes are not time synchronized. Use version control or some other similar mechanism to track your configuration files and the changes that are happening to your configuration. If you need to get back to your previous configuration, you have a way to do that if you do this. Continuing on configuration, there are some features that are key to the reliability of the cluster. One such feature that was added 1 or 2 years ago was disk fail in place. Before disk fail in place, if a disk in a data node failed, the entire data node process used to shut down. That's no longer a choice, especially considering how much storage now the current data nodes have. So configure disk fail in place, and that way your data nodes continue to run if disk fail. One other key thing is to configure name node directory restore flag to true. With this, what you would see is currently name node, which writes to multiple storages, its metadata. If a storage fails, it continues to run. But you have an opportunity without restarting the cluster to restore the storage directory by setting this flag to true. And when the name node does checkpointing the next time, if the storage is available, it will be used for writing file system image. Take periodic backups of your name node storage directory, the entire directory, not select files, because the set of directories that are there have some kind of relationship with each other. So take a periodic backup of entire name node storage directory. Also, the master on the master nodes where you have OS, those disks should be set up with RAID. Without that, if you have the OS disk fail on master nodes, it means that outage time and service unavailability until you restore the master to another node. Also, set aside a lot of disk space for name node logs and even other Hadoop daemon logs. Hadoop daemons are very verbose. And I've seen a lot of new clusters setting this to a few MBs, and these MBs are just taken away in minutes. Right? So set aside a lot of disk space on master nodes for Hadoop logs. Now, coming to another key thing that usually we have problems with is checkpointing. And checkpointing is done by secondary name node. Unfortunately, it's a really confusing name. Secondary name node is essentially a checkpointer node. I recommend seeing this video, right, if you want to understand the secondary name node and how poorly it is named. Configure a secondary name node for your cluster. What secondary name node does is Hadoop has file system image, and it records all the operations that are happening in the file system into a journal file called edit log. Checkpointer periodically takes fs image and edit log, combines them into a new fs image. Without checkpointing, you will see issues in older releases where the edit log writing could fail because name node ran out of disk space. Or also, you would see an issue where if you have not done checkpointing in a long time, name node would take an enormous amount of time to start up because it has to consume all the edit logs. In recent 2.0, where we have added high availability support, the standby name node does the checkpointing, so you don't need a secondary name node if you have HA setup. Also, make sure that even if you have secondary name node configured, checkpointing is happening periodically. The reason is secondary name node is not user affecting. That means that any errors in secondary name node is typically not noticed. This results in checkpointing not happening for a long time. Currently, the checkpointing information is available in the name node web UI. There's also a JMX or HTTP interface from where you can query it from your scripts. Do monitor this to make sure that checkpointing is happening frequently. So one real incident that happened in one of the Yahoo properties, they were running a cluster, this was 0.19 release, and they were running it for a long time, almost a year, and the checkpointing had not happened. And then one day, the dev team gets a call, and they say that they have edit log corruption because they ran out of disk space. Right? So restoring this cluster, at least at that time, was really hard. It required editing edit logs manually, and it resulted in long startup time. One change that has happened in recent Hadoop releases is we no longer, if we are running out of disk space, we no longer continue to write the edit logs to that disk. We also, put name node into safe mode. So it's a bit better with the newer releases. Do not edit the metadata files, even if even if it is in ASCII and if you think you know it. This might result in the Hadoop cluster becoming inconsistent. It could possibly also result in metadata loss. I'll tell you a real incident. This happened at Yahoo where someone pointed a name node to a wrong storage directory, and then the name node came up with the file system image in that directory. And when they brought up the data nodes, the cluster did not come up, and the data nodes could not register with the name node. Now, this ops person was very knowledgeable about Hadoop. He decided that, hey, the data nodes are not registering with the name node because namespace IDs are not matching. I know where to fix this problem. He went to the name node version file. He changed the namespace ID. Any guess what happened next? The file system name node thinks that it has set of blocks. Data node say they have another set of blocks. Name node says all these blocks are not necessary, just delete them. So this resulted in data loss. So please do not edit metadata files unless you have looked at the code and you have run some tests. My recommendation is not to edit it. Also, guard against accidental deletion. This is another case where a lot of support issues come up. Some users, issue remove-r command to a wrong directory and delete the data. Worse still, there are some admins with their super, user login end up deleting the important directories. And by the way, when you issue remove-r command, even if you kill your client-side process, the deletion continues on the name node. So the Control-C will not help you here. And undeleting these files and restoring the cluster back is a painful, time-consuming process. And we have done this at some customers, which requires immediately shutting down the name node. And I hope you guys don't delete the files, but let me anyway go over the steps that we took. You immediately shut down the name node so that the deletion at the data nodes stop, and then you go restore the files on the OS on each of the data nodes. Right? If your cluster is really big, it is time-consuming. Then you edit the edit log file, delete the entry, which is corresponding to the remove-r command, and then you bring up the name node. At least in older releases, enable trash to avoid these kind of problems. A real incident in one of our customer's place, and they were not our customer at that point in time. There was a distribution that they had been running, which did not have trash enabled. Somebody ended up deleting 100 terabytes of important data, and they called their support, and the support guy casually said, "Bring up the name node. Let me take a look at if trash is configured." Guess what happens if you bring up the name node? Name node continued to delete with the data nodes, and all the data got wiped. One key feature that is coming in release 2.0 is HDFS snapshots. Enable snapshots for your important data. That way, and do take periodic snapshots. That way, you have snapshots from which you can restore the data that accidentally got deleted. Let me also come to the next key thing, which is monitoring the usage of your cluster. One thing that frequently happens is people size all their JVMs, and then they completely forget about it. Meanwhile, users are using Hadoop cluster, the number of files grow, number of blocks grow, and then number of applications using the Hadoop cluster, they grow. And eventually you start seeing issues where name node runs out of memory, data nodes runs out of number of transceivers, processes run out of file descriptors, things like that happen. So do monitor your cluster usage and periodically do tweak your configuration to size the cluster right. Also monitor the hardware usage of your cluster and how your workloads are doing. With this, you can also tweak your clusters. It also is helpful for your future hardware decisions, and when you expand the cluster, you could suitably adjust the cluster for the load you're seeing. Monitor the usage of the cluster also with Hadoop metrics. Hadoop metrics has rich set of metrics that you could collect and monitor. I will only go over some of the key ones. Monitor your JVM metrics. This way, you can see if your JVMs are configured right, if you're having long GC process, and if any further changes are needed in your JVMs. Also, monitor RPC metrics. This gives you an idea of how the master daemons are doing. You will also be able to see if there are any slowdowns, because in RPC, you can see the time taken for each of the requests and how long it is taking the master nodes to process it. Also, keep track of your HDFS metrics and MapReduce metrics. Based on this, you will be able to understand your usage, and you can tweak your configurations further. And do monitor these things, and when you have upgrades that are periodically done, or during your maintenance windows, do update your configuration based on how your cluster is being used. Ambari is one of the Apache projects. It helps, in provisioning, monitoring, and managing the cluster. Here I'm showing you some of the screen snapshots from Ambari. The Ambari dashboard for some of the, the cluster usage, HDFS service, and MapReduce service. The dashboard covers all the important metrics that you need to look at. Here is the metrics collected for the cluster usage, where you can see network usage, the load on the cluster, memory usage, and the CPU usage within your cluster. Here is the dashboard for HDFS. You get to see how the Java processes are doing. You also get to see how many file operations are happening in HDFS. This is an easy way to detect if some applications are, abusing the HDFS by issuing unnecessarily too many commands. This is a key set of metrics to look at. And even if you don't use Ambari, these are key set of metrics for you to track in your own monitoring systems. Here is some of the screenshots for monitoring MapReduce with Ambari. It shows slot utilization, JVM status, and stuff like that. Another thing to monitor for is failures that are happening within the cluster. Sometimes, either because of rack switch failure, or because of some other condition, you could have large number of data nodes within your clusters failing. And what Hadoop does is, it starts replicating the data, and you do not want this kind of replication storm. We should, fix this in the code itself, but at this point in time, it is judicious to put your name node into safe mode and fix the condition that has taken out large percentage of your data nodes. Also track the dead data nodes, and if you can bring them up, bring it up, because you are losing valuable storage and compute resources when the data nodes are dead. Ensure your cluster utilization is less than 90 to 95%. As the cluster becomes full, the cluster slows down. Also monitor for corrupt blocks. This is important for tracking the file system health status. When there are corrupt blocks or corrupt files because of files which have replication factor of 1, which typically means that they are not important files, you can delete those files. One other thing that worked very well at Yahoo is to have a portfolio of tests or jobs to validate the cluster. This is very useful when you upgrade your clusters or when you make configuration changes to make sure and get a feel for if the cluster is functional. There are various tools that are available in stock Hadoop for managing your clusters. Use Balancer, and what Balancer does is it takes all the data nodes storage utilization within a certain band that you specify. Doing balancing periodically helps in making sure that the storage is distributed across data nodes. And by the same token, because you are distributing the storage, you also end up distributing your computation across the data nodes that are in the cluster. Also, make sure that when you are doing data node maintenance, you decommission the data nodes, and once it is decommissioned, you can take it down. That way, you have more control over the replication that's happening in your cluster. One other thing that I want to highlight here, and this is something that ops people can use for building tools for monitoring and managing the cluster. There is, we added a lot of the information that's available in name node web UI into JMX. Prior to that, people used to scrap, used to take all this information from name node web UI. You no longer need to do that. You can use HTTP interfaces to get all the information that's available in name node web UI, and some of the information such as how many corrupt blocks you have, under-replicated blocks you have, dead data nodes you have, your data node list that is registered. All this information is available over HTTP, the HTTP bridge to the JMX that we have. To further simplify management, already in case of Hadoop, because Hadoop is built with an assumption that nodes and disks fail, the cluster is reacting to such failures and doing replication or running some of the tasks again, and that is how the failures are dealt with. This is different from other kinds of solutions that are available out there, where instead of HDFS, which uses replication, that is, it keeps multiple replicas of data distributed across data nodes. There are solutions that are built on RAID, in which case, if a disk fails, you may have to rebuild the RAID, and you have to do it quickly. You have to react to the problem, and that is not necessary in case of Hadoop. Also, in case of Hadoop, when the nodes fail, because there are multiple nodes participating in rebuilding that data, the healing happens much faster because it's happening in parallel, unlike RAID arrays. So given that it is, and this is how some of the large clusters run, especially at Yahoo, have some spare cluster capacity that accounts for the failures that are happening in the cluster. This gives you a flexibility where, let's say if you have 10% more capacity, you don't have to react to the failures that are happening in the cluster and fix the problem immediately, especially the problems related to hardware. Instead, you could wait for a longer maintenance window, and you could do it in maybe a couple of weeks' time, right? And you could fix all the failed nodes once in a couple of weeks. This helps in simplified management, and at Yahoo, if you see, a single operator manages 3 to 4K nodes, and I'm sure some of the Yahoo folks will say it's much larger than that. Going to designing for multi-tenancy, Hadoop clusters are typically used by multiple users and multiple projects. Making sure that the cluster can be utilized by all of them as a shared cluster is very important. So in order to do that, to share the compute capacity across all the users, use a capacity scheduler. A capacity scheduler provides you a way to configure queues and sub-queues where users can carve out some capacity that is available in the cluster for themselves. This also, it's sort of similar to users having their own separate cluster. It's better than that in a way that if there is unused capacity within the cluster, users can also make use of that. For sharing HDFS storage, make sure you configure quota, both disk space quota and namespace quota for users and project directories, however you're organizing your data. Making sure configuring quotas will ensure that some rogue applications or some faulty applications cannot end up using a lot of cluster storage disproportionately. Also, with federation, you have a choice of running multiple namespaces. You could make use of this for running separate namespace for different kinds of application, say production versus experimental applications. You could possibly use this for also different kinds of applications that have different requirements, such as HBase with low latency requirements. So you could isolate your different kinds of applications to separate namespaces. One other thing that worked really well at Yahoo is Yahoo not only provided Hadoop clusters as a service, that is, there was a dedicated, knowledgeable ops team that managed the cluster. There was also a team that trained users. So making sure, instead of telling the users that their applications are misbehaving, it would be good to make sure that you train them on the best practices of how to write applications. Also, you could encourage them to use replication factor of 1 for temporary, not so important data. You could have them periodically delete unnecessary data so that this data is not taking up cluster resources. You could also move some of the cold data that is not being used into Hadoop archives. That way, you are reducing the number of files and blocks, and make it easy for name node to manage the amount of data you have. Encourage your users to use a replication factor of 3 or more for their important data. If they end up using replication factor of 1, some of the node and disk failures can result in loss of data. So it's very important that they use replication factor of 3 or more. The other thing that worked well at Yahoo, and also some of the customers I have seen, is to set up a small test cluster. I've seen a lot of customers using their production cluster, stopping all the production jobs to debug problems. It is important to set up a test cluster where you can run some of your tests without affecting production jobs. Set up a user mailing list within your company so that your users can exchange information, learn about problems instead of everybody discovering problems during upgrades and things like that. That information exchange helps in identifying problems quickly and reacting to it. Also, encourage your users to create Apache Jiras and participate in the community. That way, the community overall benefits from the issues that are found, the suggestions that are there. So that concludes my top 10 things to do to get most out of your Hadoop cluster. I left out a lot of things. For example, I have not covered security at all, which is an area which is not well understood, and a lot of support tickets come. I have also not talked about how to tweak HDFS for better performance. I have not talked about MapReduce and what parameters to tweak and what parameters to look out for. I guess that could be covered in a future session or maybe in another forum. So that is my talk, and if there are any questions, please use the mics that are there, and I'm ready to answer. I'll make this, these slides will be available, and I also, plan on having some kind of a wiki that is available to users where we can continue to expand on this. Also, if there are any other important things that you have discovered, please reach out to me, and that will help in keeping the wiki up to date, and maybe I can incorporate that if I present this again.
Yeah, I know you covered a little bit in terms of JBods and RAID, et cetera, but where do you see the role of shared storage in Hadoop clusters? You think it's imminent?
A lot of people want to use SAN storage, especially with the emerging use case of using VMs to run Hadoop. My personal opinion is I think the architecture right now we have where we move, one key thing with Hadoop is you move computation to where the data is. That means that you are mostly running your processing on local disks and very rarely across different machines. So that gives you enormous bandwidth. The other problem that I also see is in case of Hadoop, you are getting huge aggregate bandwidth, right? So your theoretical maximum bandwidth is all the number of disks and what is the I/O throughput that you get from the disk. I don't think SANs can handle this kind of throughput. So I am biased towards local disks. However, SANs, also not just SANs, there are also other solutions that are becoming available where people want to run their Hadoop clusters against Swift is also happening, right? Or Isilon, things like that. Yeah, but if you separate storage from computation, you lose the kind of aggregate bandwidth that you get in a typical Hadoop cluster. So that's a great question. The question is, do you have any best practices for upgrades, and also talk about some of the future upgrade changes that are going to come in Hadoop 2. The upgrades that we have today are, it requires an admin to do the right steps. When I talked about do not edit your metadata files, one such incident is somebody ended up upgrading to a new release, and they ended up rolling back in the same new release, and thus they lost their ability to roll back to the older release, right? So the upgrade and rollback that we have is quite brittle, and there are some improvements that are needed there. As regards to best practices, I think you got to be really careful in executing the steps in the same order. If you do not understand, if you execute them in the wrong order, it could cause some problems. Also, in case of Hadoop 2, what we have now is we moved from previous wire transfer protocol that was all based on Java serialization to protobuf. So protobuf lends itself to some of the changes that keep two versions of protocol compatible. Also, there is a more emphasis in Hadoop 2 to keep all the wire protocols and API compatible. That enables us to do the rolling upgrades. Rolling upgrades themselves, in case of HDFS today, though there is no automated way of managing it, you could, in 2.1 onwards, you should be able to start upgrading data nodes, at least, to start with in minor releases. And there is also similar work that is going on in Yarn, where, RM restart is one of the work that is happening for rolling upgrades. There is also some node manager related enhancements that are being considered. I think some of these things are okay. So the question is, based on your experience, what is the ratio of CPU cores to the spindles? It depends a lot on your workload. You might have heard, some of the recommendations which are based on, balanced hardware, and if you're I/O bound, have more disk spindles. If you are memory bound, because of the kind of applications you are running, go for more memory. And then, same is true with the CPU cores as well. So I need to wrap up. One last thing. A lot of what I have presented is not just the information I have gathered. I have learned some of these things from some of our Yahoo ops people, and a lot of the credit for some of the things I've accumulated here goes to them, Charles and Alan. Thank you.